Alright, five-step method. This is going to be used to do all of our factoring. Okay? It's a method I created. So there aren't any books out there that have it. So really pay attention, focus, because only students that I've taught will be able to help you with this, unfortunately. Okay? I'm going to try to teach the tutor this, and if they're willing, and also maybe the next math teacher that's coming in. Okay? Here it is. First step. Okay? First step in the 5 steps. So this is the 5-step method. Okay? And the first step is GCF. Okay? The second step is what we call a star variable and parentheses. So parentheses, star variable. The third step, okay, is going to be signs. And the fourth step is what we call product, or it's a big pi, okay, which is a Greek letter, okay, and sum, which is the Greek letter sigma, okay, and we use sum for summations later on in statistics and calculus, and we use pi, the big pi, for productation, which is used in statistics and calculus. So these are signs I'm teaching you. They're new, but I'm just using them more as symbols than as what we're actually doing. So symbols. So product, pi, product, p, and sum, sigma, sum. Okay? And then the fifth step is star cleanup. Okay? Alright, so first step is GCF, greatest common factor. I want to find the greatest common factor among these 3 pieces in the trinomial. Okay? So, is there a number that goes into 1, 3, and 4? And the only number is 1. So, the GCF is done at this point. Okay? So, GCF at this point is done. Alright? So, now we look at what's called my second step with the star variable. Okay? And the star is always this number, the number that's out front, the first coefficient. But in this case, there's not a number out front. Well, there is. It's hidden. It's called a 1. But we don't care about a 1. The 1 doesn't bother us. So it's not going to affect the star. So when there's no star, there's no star cleanup. Okay? So that's cool. So this problem right off the bat is telling me it's 3 steps. I'm going to do the variable in parentheses, I'm going to do signs, and I'm going to do the product and sum. Okay? So, my first real step in this problem is actually the second step, which is my parentheses. I always make 2, because we take this trinomial and we create 2 binomials from it. Okay? The next, within this step, I said a variable. So this variable, and I'll take the square root of it. Okay? What that means is, if it's x squared, I'm going to take an x, because there's 2 x's, right? If there were 4 x's, then I would put 2 and 2. If there were 6 x's, I would put 3 and 3. Does that make sense? So these have to add up to be this many. Okay, so that's our second step. Done. Simple so far, right? I hope. Okay, now, signs. Okay, what I do is I take this sign and I bring it down. Straight away. Every time. This sign goes here. This sign goes right here. Okay? Then I look to this sign. this sign tells me whether these signs are different or the same. So, if they're different, this sign will be a minus. Difference. Different, minus. Okay? So if it's a difference problem, alright, then these two signs will be different. If this problem is a plus, this sign is a plus, then they will be the same. Okay? So when this sign is a plus, these two signs are the same. But if this sign's a negative or a minus, it tells me that they are different. So one's a minus, and the other has to be a plus. Okay? So signs is taken care of. Alright? And now we want to take care of what's called product and the sum. Okay? And now the product is the first number times the last number. Okay? So the first coefficient times the last coefficient, the third coefficient. So 1 times 4 is 4. That's my product. What's nice is the sum is the middle number. Okay? So the product of first and last and the middle coefficient. Alright? And in this case it's 3. And we don't care whether they're plus or minus. Doesn't matter with what I'm doing, with my 5-step method. Okay? Doesn't matter because we already took care of these signs. So signs are done. We don't care. We just take the number. But what we do care about is if it's a difference problem, which it is, right? Then this sum becomes a difference. Or remember when I talked to you in the first chapter, I said, really want you to know that when we subtract something, we're adding a negative. And what we're doing here is going to be adding these two numbers, but one of them is negative. And that's why, in this case, this difference problem, we're going to be adding a negative. So we're finding the difference. So we need two numbers that multiply to be 4. So it's like, and we always put the greater number first. So 4 and 1, or 2 and 2, right? So those two numbers multiply to be 4. Those 4 numbers multiply to be 4. Okay? Now, we need two numbers that multiply to be 4, but are different. Different, because this is a difference problem, by 3. And right there we can see that it's just 4 and 1. 4 and 1 multiply to be 4, but they're different by the amount of 3. So now all I have to do is put these in their place. 4, 1. Okay? So, my product and sum is taken care of. Now it's time to do my star cleanup, but there was no star, so I have no star cleanup, so I am done. So my final answer is x minus 4 times x plus 1 is equal to x squared minus 3x minus 4. So if I were to do the clam method, then x times x would be x squared. X times 1 would be plus x. Okay? Negative 4 times x is minus 4x. And negative 4 times 1 is minus 4. And when I take my like terms, I get x squared minus 3x minus 4. And so this is this. They are the same. It's just factored. Okay? So that's your first problem.